Hello and welcome. I'm Bill Wake. We're working on a parser combinator library. We'd been doing some work on evolutionary design of switching from an old style parser to a new style parser. And along the way, we learned some lessons about our library. We want to incorporate those. What are we looking at? Well, it's a number of things. The one we're going to focus on first is error handling on the or else. Okay. And the rule is going to be if parser one succeeds, it's parser one or parser two. If parser one succeeds, then we're done, return the result. If it totally failed, it said, I found an error right away, then we're going to try the next parser. If it failed, but it made some progress, we're going to return that failure result. So the original one did total backtracking, and if it failed but made progress, it did try the next parser. So we're changing the way that works. That'll help us with our error handling. The second one is the optional operator, and we're going to do something similar. If it's successful, return the result. If it makes no progress, return an empty result, which is a success. And if it makes progress but it fails, then return that failure result. So again, it'll help us if something got partway through an optional, we'll record it as an error. We already did this next one, which is we're going to keep the old operators as bar and question. They allow the backtracking, and sometimes you need that, so we'll do that. Then we have a couple operators we added. A new check operator that can checks and returns a value with a parse result instead of an optional, and an inject that puts a hard-coded value in the stream. And this is useful because sometimes if you have or, you need to have the same result. And so maybe we need to insert a token or something that just helps it out a little bit. Let's see. The last thing is the old check operator. We're just going to delete. We got rid of it in our code, and I think the new one's the better way to go. Excuse me. Alrighty, let's go back over to the IDE. Whoops. All right, back in the IDE, we ran tests. We started in on the or else. Let's see. Here it is. We ran tests and it failed some of our tests. So we think it's good. Let's see, here we go. We take parser one and run it. If it's successful, we return the result. If it fails and the index equals the start index, then that's saying it didn't make any progress. We return the second parser. Otherwise, we just return the original result, which is a failure. Okay, and we're failing two tests. These are grammar tests of basic multiple statement ambiguity. So we're simulating 100 if A, then print 1, else print 2. We're leaving out the arguments just to kind of simplify things. But we do our parse. Let's see, where's parser? Whoops. Back here again. Oh, basic line parser. Okay, let's go look at that. All right, so this is going to convert strings to statements. We'll match the string 100. We'll match the string print. We'll match if go to, or if match, if statement, statement colon statement. Okay. And when you put this all together, you got print, if go to, or if statement. And the thing to notice is they both start with, these two both start with if. Okay, so we have an ambiguity because you don't know which if you're getting until you get past it. Is it the if go to or the if print, if multiple statements? Okay, so we parse this thing, and it's really the multiple statement one. What's the failure? Did not find expected value. Well, that's a pretty weak message, but it failed at number 2. So it got past the if and didn't find the value. Okay, so we basically that if with backtracking would pass. Let's change basic line parser. So if you recall, our original version was if with backtracking, which is now written this way. Okay. And this is this second one. Other ones might fail when I switch it back, but we'll see. But this one should pass now. Okay, they all pass. Yeah, because this test was written with that in mind. Okay, and so this nested ambiguity was the other one. If A, then print. If B, then print. So the print and the if B, let's see, the if B, then print should have two prints. And the A should have two statements. Okay, so once again, we're using the basic line parser, which uses the fact that you can back up past if in the go-to case or the statement case. Okay, I believe we tested OrElse on Friday. Yeah, we've got the tests for these. So that was more of an integration test, kind of. So I'm content with OrElse. I guess I should have made a better title for this session, right? We'll commit. All right, and then in our list of things, let's make this one a check now. OrElse, and let's go on to optional. Oh, let's see. I've got my to-dos are in this file over here. So what we're up to now is optional without backtracking. Okay, and let's find optional tests. Okay. All right, and then I'll just move this over, close tabs to the right. Well, we should update our README. Okay, alternative. Okay, this message is actually about the backtracking alternative. Returns the result of the first parser if it succeeds. If it fails with no progress, it returns the result of the second parser. If the first parser made progress, it returns made progress but failed. Okay. And it is not the backtracking alternative. Let's turn that around. If the first parser succeeds, returns that result. If it fails with no progress, it returns the result of the second parser. If the first parser made progress but failed, it returns the failure result. Okay, that is true. All right, there's no corresponding issue on the sequence one, but the optional, again, this is more speculative at this point, but we're saying this is the backtracking optional. Optional 0 or 1. Okay. Excuse me. Succeeds whether or not the first person does. Okay. If the parser succeeds, it returns the success. If the parser fails with no progress, it returns nil. If the parser made progress but failed, it returns that failure. Okay. All right, and let's make that happen. Optional tests. And optional Swift. Okay. So we want to add this one. I don't know, but I'll put them like that. Okay, and we're going to rename this optional with backtracking. Make sure the tests run. Okay. And now we want to find the places, well, I guess we'd like to use this operator if we can, but in the optional tests, we definitely, let's make these optional with backtracking tests. Optional. Okay, and they really need this operator. My other tests that use it, I'm kind of okay with that. All right. So we update test. All right, and then let's add the optional tests, and they've got to have 3 cases, right? So we know there's one more test to write. Okay, optional tests. Okay, optional with a match. That should be fine. Optional that totally fails to match. Okay, so it's looking for a 1, it sees a 2. All right. Returns nil. Whoops. Optional with match returns success. How about returns matched item? And then finally, we got an option that fails to match. Optional that, oh, is this going to work? Totally fails to match. Yeah, but we need that partially fails to match. Returns failure. Okay, all 3 of these have to be our single operator. Okay, and do I have a set 2? I don't think I do. Okay, so if our grammar on this last one, let's say it's an optional sat1 followed by sat2, and our input is 1, 3, this should be a failure. And let's make this, let's give those messages. Okay, expected 1, expected 2. And the message should be expected 2. So we match the 1 and we fail to match the 2. So the whole thing, the backtracking version would say the whole thing is optional anyway, so it doesn't matter if you didn't match the 1 and the 2. This operator should say it does matter. All right. And whoops. Expected argument type. I have to look at check failure, I guess. Expected parse result. Okay. Should be a failure. The position is an int. Well, it's going to be at position 0 because we didn't make any. Oh no, position 1 because that's where we didn't find our 2, right here. And the message then is expected 2. Okay. And the first 2 tests should pass, and the third test should fail. Okay, let's make sure it's the only one that failed. Yeah. Okay. So what did we get? Well, we got a success, array slice 1, 3, meaning that's the rest of the input. So we, with the backtracking version, we do expect to be able to continue. Okay. And I'm going to take this test and put it down here too. Still returns nil. Okay, so this is the optional operator, and this should be a success. Nil with the input still being 1, 3. And we'll take set 2. Actually, let's take them both. It might change some results, but a little more accurate wouldn't hurt. Well, the first one can't fail, so it won't matter. Okay. Cannot find set 2. Good, good. Okay. This test should pass, so that's kind of the contrast between them. Okay, the only failing test is this one, so it does pass the old style with backtracking. Okay, let's implement optional with backtracking. Well, I'm going to rename this file. Just make it optional. Okay, and well, let's check that in. Oh no, we're failing tests. Let's not check in. Okay, the deal. No, I lost it. Okay, so we need a new parser, a new class, and they're just so similar. I really am putting them in the same file. If that's a mistake, let me know if you're a Swift person or anybody with an opinion. Okay. hopefully that helps things. All right. So the trick is the parse. If you match successfully, that's good enough. Okay. Failure is different. We don't return success with nil unless basically it's kind of like the OrElse test or the OrElse situation. If your input equals the start index, then we do something. Okay. Here it's not, we don't go into parser 2 because there is no parser 2, but we do return this. Okay, so if you didn't get anywhere, return success, otherwise return result. Okay, so the original result with the failure. Ooh, what? Now this may be another issue. This one, index. Oh. Let's do that for a minute. Should fix the first one. Okay, yeah, this one's a little different because well, the return type's in a different domain than the source type, basically. So since the return type can return nil, it needs a new result. So it seems odd to just copy these things in, but it's just shifting the type from the input domain to the output domain. Okay, and you can see the input target is the same, but the output target is different because now it's optional. Message. Yeah, that's a spurious message. No? Let index less message. Let me clean build. Cannot find message. Did I spell it right? No. Ugh. Run tests. Should pass. Notice we have 3. Yeah, so much for that. 3 paths. Let's see what's the problem here. Expected to, but got a success. Oh, I know what I didn't do. I didn't change this to just optional. All right. Now I expect my 3 tests to correspond to the 3 paths through here. And let's handle optional without backtracking. Okay. All right, I think that is adequate. Let's see, where's our other window? This is, what else do we do? Okay, we handle non-backtracking optional. Okay. Okay, that was this one. Let's do the same bullet. Okay. And let's go on to this one. Okay, so the check operator. All right, this one, we already did the work. Okay, so this may be a short session on the parser combinator. We're gonna go from there. Okay, so let's see. So optional, we've updated that. Now check. Did I not include it? Oh, there it is. What's that under? Specialized. Okay. Check. If the parser fails, return the failure. If it succeeds, run the check function. If that returns nil, there was no problem, so return the parser result. If it is nil, it returns location and message for failure. Okay, we changed that in our interpreter. And so let me pull this over. All right, so we introduced this version. It's check 2. We called it here, but I'm going to call it check back in the original. So what this one does, you give it a parser and a checker function. And the check function doesn't return an optional. It returns an actual parse result. So this version, let's see, the check function returned an optional. Well, this int and the string are really the failure clause on the parse result. And so basically the checker, the only thing it does is fail. We'd like a check that can be kind of put in the pipeline and do a transformation as well. So it returns a new target type, which could be the original. And because it returns that, it can return a parse result that includes the new target. Okay, so what does it do? Well, it runs the parser, and then if the parser failed, it's a failure. Okay, and then if it succeeds, then it runs the checker. So it's making a pipeline kind of thing. So it runs the original parser. If it succeeds, it returns the result of the checker function, which is sort of a parser. Its input is not the same. Let's see, because it's a different kind of function. It takes a target and an input. Is that right? Oh, no, it really is a parser. Yeah, okay. It's a parser, right? Check, let's see, parser. Down here. Parser, oh, only takes an array slice of input. Okay, yeah, so it's almost a parser. I guess that's the way to say it. Instead of just taking an array slice of input, it takes the previous target. So it kind of combines. We have a mapping operator called pipe that converts an operator, a result from one type to another. This one is basically the combination of a parser and a mapper. And so its input is a little different, so it's not a pure parser. We could have made the input the target, but then where's the rest of the input going to be? It's going to be in some other type, so it just doesn't line up. But I think it's pretty simple, so we're going to live with it. All right, so let's... we have tests for this too. So since this thing is tested as well, I'm feeling good about just pulling it in. So we will we'll take these and pull them into our library. Think of it as kind of well, it's not really a PR, but it's kind of like that, right? We're accepting some other stuff. Okay, so let's add check 2 tests. It's really a test case. Well, that certainly didn't go smoothly. Yeah, we need to import pcombo. XC test, yeah, that's fine. Okay, we made up this new operator. Okay, but this file should be check to tests. And we don't have an operator like that. Okay, so let's go to check. And I'm going to put it up here. And back here. Okay, so this is called check2. It's got its own operator that we don't define already. Okay, so I think our test should pass. Let's make sure it builds. Okay. Okay, so added check 2, which is pipe and grader operator. Had already implemented in the Bassi project. Okay, now let's get our README straightened out. Okay, so check. Well, that didn't work. If the parser fails, return the failure. Yes. If it succeeds, run the check function and return its result. Okay, so that's clearly a simpler thing. And let's pull an example from the test. Parser combinator. Check 2 tests. Basically the same example. Okay. This is going away. And this is going away. Okay. Okay, and then let's remove the old one. Let's see if anybody's using this. Only the check tests. Okay, so we can remove check. And its tests. And our test should be fine. Okay, now we have this as check2. Let's rename it. And rename our file. Oh, I left out part of the rename, didn't I? All right. That was check2. And then the other one is inject. Okay, so inject, its goal is to insert a new value. So all we do is we get that value as the thing we're going to inject, and the parse returns the value but doesn't move forward on the input. So it's just inserting a new value in there. Okay, and it's got a test as well. Inject tests. Okay. And I'm violating the case rules for classes or guidelines. Normally classes have capital letters, but the way we use these, they look like they're functions, so I do them with lowercase. I think that's the right decision, but yeah, you tell me. Okay, this, I got that twice. Okay. All right, so the function doesn't exist. Let's go ahead and add the class. Yeah, there's just some weird bug going on. It should stop being asked me what I want to call it. Oh, this one probably same thing, yeah. Okay. And we'll pull in the inject test. Okay. Probably more important to import pcombo. Oh no, this is pcombo. Okay, let's make it fail just to kind of reassure ourselves. The test should fail. Oh. Oh, I redefined. I made a new definition. That's over here. This is an extension on parse result. Success target, is that what it was? Success target, success remaining. And we expect a failure. Okay. It failed because we claimed there was going to be a success target, and it's a failure. So let's get the real answer. Okay. Inject tests. We probably could use this elsewhere, but I'm not going to pursue that right now. Okay, success target string. So if you look for a 1 and you say inject a string in front of the 1, you get you basically get a tuple back that's the string in field 0 and the 1 you were supposed to parse in field 1. And you still have this input left. Okay. The reason for this awkwardness is you can't compare tuples directly. They can't be equatable. I don't know why. It seems like a very simple. It feels like a flaw in Swift, and maybe they'll fix that someday. All right. Cool. So let's push this in. Add inject parser. Inject something. Returns something. Okay. And we need to document that. And again, I think that's another specialized one. Okay, so let's, there's no operator. Inject value. So inject value and parser. Returns the value. And the result of the next parser. I think that's true enough. Hard-coded value. And the reason for it is this makes it easier this can help you make two alternatives produce same type of result. Okay. Anything else? Update documentation for inject. Okay, so everything's running. All right, so we need to do a tag. Let's see. Looks like we're up to 1.1, 0.1.1, or up 0.1.2. So what we should do, we're going to tag this as 0.1.2. guess we will commit this. Push. Oh, I don't really get a place to put my message, do I? Well, pretty sure it's just me still, unfortunately. Or fortunately, depends how you look at it. Okay, 0.1.2, 0.1.2. All right. So I think we've successfully updated our parser combo library. This is probably a good time for a break, but we'll come back from the break and we'll switch back over to the Bassi project and update our combo library and see what we can get from there. All right, so about 3 minutes. Welcome back. Okay, we're switching projects. We're going back to the Bassi interpreter, and our goal is we're going to take the library we just updated and try and introduce it into our interpreter evolutionary design project and get some better error handling. Oh, inject. I make this mistake all the time. I don't know a good way to check for it though. All right, what's the mistake? Well, it's back in P-combo. We defined the new inject. Inject. I said it was public, but I didn't say the initializer was public. That would feel like it's worth a warning or something. Okay, everything about it is public, but that. All right, and because my tests are all local, they don't care. Let's check this in. And let's make sure check is the same. Yeah. Okay, public function, good. Okay. Let's go take this. You know, to be fair, let's make at least call it 0.2. Tag it. I mean, it is a breaking change, so at least go up a little bit, even though it's under 1.0.0, so it's still experimental and you can kind of muck around a little bit, but I think we are better this way. Yeah, let's do the many first. Okay. So I'm saying there should be a new test. Many with no matches returns empty array. That's good. Many with one match works. Many with multiple matches works. Many with multiple parsers and multiple matches should still work. Okay. However, okay, I'm back in P-combo again. We're back in P-combo, and we're going to add a test. A many that partially matches returns a failure. Okay, so we'll take this one for a base. Okay, so our grammar is going to be sat1. Do I have 1 and 2? Okay. I'm going to have sat1 and sat1. Maybe it's just ansat1 ansat2. That probably suffices. Okay. So if you have one, you're expecting 1, 2, and you match 1, that should be a failure. And oops, is it just the message? Okay, let's put messages on these. Nobody was failing before, so nobody cares about those messages. I don't anticipate a problem there. But the check failure, I think it just looks for a message, right? Oh, it looks for a parse result. Dot failure, okay. It should fail at position 1 with the message expected 2. Okay. So expect sat1 and sat2 repeated, 1, 2, 1, 2, 1, 2. It sees a 1 without a 2, which partially succeeded. We would like to have a message there that it got in there and just died. Okay. And this test should fail. The others should still pass. Alrighty. Good. It got a success because it says, oh, I just don't match anything. That's fine. All right. Now my question is, do I need to provide the backtracking version? And I don't think I do. Right, because I can always provide the backtracking optional around it. So I think we can just default to this. Again, it may change more than I want, but that's the way it goes. Mini.swift. Okay. All right. So you match, and then how do I do this structure? So what I want to do is get a result. Okay. And if I fail, I want to fail. So I think we'll try a while true. And switch on result. Okay. And a failure is the easy case. Let position, let message. If it failed, well, okay, let's fill the other case in. Dot success. Let value. Let remaining. Okay. If I get these, I'm doing this. Okay. This is not going to work, is it? Okay. If I hit a failure, I definitely want to return a failure. I don't know if I can return result. It may be the wrong type. Yeah. Okay. The target differs from the target of this parser, so I have to make a new one. So I'm going to make a failure. Well, I'm going to make this basically minus the lets. Okay, if I do this, I fail. Oh no, this is, I have to look at the failure. Okay, if the position is last remaining, that means I didn't fail directly. Okay, yeah. Many position equals last remaining dot start index. Okay, if I failed at the start index, that means I didn't match it at all. Okay, then I got to break out of this loop. Okay, because that's the norm. That's the case here. If it's not success, it was a failure, and we should break out of the loop. Okay. I don't know if I can. Yeah, it's too complicated to put in the while. If I do the success equals that, and yeah, I think this is better. Okay, so let me take these out. Wait a minute, that doesn't sound right to me. The error message there will never be executed. Does that seem right? I don't see how it does. Oh, we know result is failure when we get out of the loop. Okay, I guess that's... If this came up never executed, that would be a problem. But I guess it knows that the only way out of the loop is because something failed to match, which is what we had before. If something failed to match, we leave our loop. Okay. I believe this will work. It is definitely more complicated than I want. I hope I'm not getting myself an infinite loop somewhere. I'm afraid by the fans, I believe I am. Let's just start with the many tests. And let's just do the basic one. Even that fails. Okay. So much for this reasoning. All right, let's back this out. Scope changes. All right. What I think I want to say. Okay, so now I have a failure. I think maybe this part's okay. We pulled things that were successful while they were successful. We hit a failure. If right, we definitely hit a failure. Okay, so if the failure if let failure position message equals result. Okay, that has to be the case at this point. Because we no longer have success, we must have failure. So that seems like it should be true at this point. Okay. Is a compiler going to know it? I guess that's the real question. Okay. It is not exhaustive. If case, yeah. And I don't need the word let because I'm already using it. Immutable. Missing return. Okay. I think the compiler is naive at this point, because we know the only choices are success and failure, and we know we exited the loop, so it must be a failure. But we can satisfy it with this. Okay. This to me should be a neutral change. One way or the other, we return success. Okay. And the one test that should fail is our new test. Good. Okay. All right. I think I'm on a better track here. Okay. So now, if the position, we really care about the position. So I don't know. Can I get to it? Remaining. I think my claim is if last remaining. Let's see. So let's say we go in and we say parse last remaining, and it comes back and it says I failed partway through. So my index is greater than last remaining dot index. Okay. Um, then I'm a failure. Okay, so failure. Whoops. Position message. Okay, now this should break the way the others broke. So let's run one test. And I believe it will infinite loop. No. Will it infinite loop? It'll fail. It'll just flat out fail, I think. Huh, what do I know? Oh, there it is. Okay. Yeah, so it expected a 1. Right, because with this, the way it is now, it gets as many as it can, and then eventually it failed, so we got a failure case, and we fail and we say fail. Well, we used to say success. But the condition is it's really and oh, I bumped. Okay. I can't get that up when I hit this key. Oh, I can. Okay. I don't know why. All right. If failure in position and the position is greater than last remaining dot start index, okay, that says we made some progress. Position. Okay, I guess I can't use it. Is it comma? Okay, I think I can use it here. I don't know why I can't use and. I guess the comma's enforcing the scope existing where this now exists, where the and does not. Okay. If the failures at position and position is greater than we made some progress, it's greater than where we started, last remaining, then it really is a failure because we just didn't get there. If it's equal to last remaining, it can't be less than, but if it's equal, then it just didn't fail. It failed right at the start, and so we just go back to returning success. So I think this file should be happy. Okay, and I think all the tests should be happy. Okay. So okay. So I think that is okay. All right. Let's release this 0.2.1. Okay, I think I can do it. Yeah, let's commit this. Okay, so make star fail if inner parser fails partway through. Okay, and then release. Let's tag this 021. Again, I'm not really following semantic versioning. I guess I am. If I'm in the 0, I can do whatever I want, but it's a moderate change. Okay, so, and let's push that. Okay, and we'll bounce back to the other project, do an update. And let's just run this one test first. Oh, it broke at my breakpoint. Okay, I was curious if it would there. Oh, sorry. Print $0. No. Okay. Well, broke there, but it's not helpful. I hope it's not a problem. Okay. We got our type mismatch. Run them all. There's going to be some that now succeed that we don't care about. Okay. Type mismatch. Good. And we still have to do our plus. Okay. Next one, type mismatch. Good. That's definitely the case there. Again, an integer function calling a string. Missing that. Well, let's come back to that one. Missing parentheses will come back. Factor not. And that one's interesting. Okay. Expected a data value. Okay, that's the correct one. So we would rather have it say expected a data value at this point rather than junk at the end of the line, even though they're sort of both true. Missing line number after comma is error. Missing expected character, yeah, it's okay. I think I'm going to leave this one as a to-do still. Can we get a better message? Yeah. Okay. So let's run these again. It should be a smaller set, but not empty. Okay. So this one, missing left paren, that is what we wanted. So let's take our win there. Well, it's kind of good. I guess we're looking for a match after this call. We definitely expect a parenthesis. Okay. Yeah. And when I have the to-do that was already there, it really says we had that message before, but we had to live with the worst message for now. Missing left paren. Right paren. Expected start of expression. Okay, this one is that might be as good a message. Oh no, missing expected character. I'm gonna get these two passing and then deal with the to-do aspect. Okay. And this one. Missing expected character. Really, I'm expecting an integer there. Okay, so these should pass now. But I still have some to-dos. Okay, so let's improved error messages from updating P combo. Star now has no backtrack semantics. Okay. Okay, so let's look for these to-dos. Improve messages on to-dos. Maybe we should be more specific. Better message. Okay, expecting character. So let's look at the on statement. Okay. On match one comma. Okay, so this look at the test. Expected character. It found the comma, but it didn't find the integer. Match one. Okay, this thing is defined in our token matcher. Okay, I think this is really just a consequence of this. Integer is really just an integer. So I'd like it to say expected integer instead of whatever it is saying now. Oh yeah, there we go, missing integer. Missing, maybe it should be missing expected integer. Wait a minute. Okay. To token list for match 1. Missing integer. That's probably okay. All right, let's find our other to do. This one, expected start of expression. Okay. Missing expected character. All right, so we've got to look at our grammar again. Is this expression tests? Parse expression tests. Where's my file? There we go. Expression parser. Okay. And this one is basically, I think the error happens here. Okay, so, all right. So once you've come in, this is factor. So when you come in down at the bottom, once you get past all the parentheses, we expect to see a number, an integer, a string, a variable, or a function. And we're not seeing it. Sorry, we're not seeing any of those because we're seeing a star. And that can't start any of these sub expressions. So we expect to see expected start of expression. I think maybe name parser I don't know if name parser needs to mark progress. Like, is it showing up at some point? I don't know if I can make. Let's make a temporary change. I'm going to say comment out this. Comment out this. Okay, so I'm only allowing left parens or numbers. And I'm going to trace this guy coming through. It should get here and say you're not a left paren or a number. And expected start of expression. Instead, we're getting something else. So this breaks It's not a great way to do this stuff. Yeah, let's see if I can find a way to break where I want to break. I guess that's in name parser. Or name. Let's break here. Okay, so if I run this test with this, well, I really expected start of expression, because that's really the only legitimate thing there. Run this test. I should break on name. Okay, and let's result is a failure. Position 5, missing expected character. Well, that's a surprise to me. So that's a wrap on the parser combinator work for today. We've got the mini parser to allow partial results and return failure on that. I think we need to look at many 1, which should be similar, and then the separated by operator that lets you repeat like comma separated lists and so on. Again, we should double check that we handle that correctly for partial results. We have a little work on those to do tomorrow. Otherwise, we'll be done with this parser combinator project and do a little work to integrate it into the basic interpreter again. Thanks. Take care. Bye-bye.